Okay, hello everyone. There, um, I'm using this new, couple of days now, and I have a little difficulty with this sometimes. So, welcome to another problem session. Well, this is from the same places I have been doing this recently, and this is question 14. So, this is actually pretty interesting problem in the sense that you don't need to do almost any work to get it right, just to draw some pictures. So here there are two dipoles, and we have to guess. So what's the electric field going to be over here? Dipoles, so you have to know what dipole is. Dipole is a minus charge Q over here and a plus charge Q over here, and the distance between them is d. Then we say dipole moment is q times d, not 2q, just one of those q's, times d. This is dipole moment, not momentum. Two words, dipole moment. Okay, so and the direction, when you say p as a vector, then it goes from minus charge to plus charge direction. So that these guys are like that. And if you take a d, d is small, limit d 0 of qd, and so with p constant, then you say this p is a point dipole, and you just represent this with an arrow like that. Okay, so over here, question over here is, well, is one of these is correct? I need to guess or work it out. I don't recommend working these problems out unless you remember the formula and then you can work it out, but it's not necessary. This one, the same problem, but dipoles are flipped here, and this dipole is pointed to the right, and these both point to the right. Okay, how would I do it? Let's look at it. I'll try to guess just from the direction, direction first. And this is 0, no direction. So from that part alone, we should be able to figure some out. So this, let's see, if I look at electric field will go down here from this guy. Electric field will go down here from this guy. Both going down the same amount. This is going to add here, and it's going to be minus j hat. So clearly this guy, P is not 1. It could be 2, because if magnitude is right. Can't be 3, can't be 4, can't be 5. So just P is definitely 2. P goes to 2. So if I look at the answer here, okay, that gone, just C and D left, right? So, and this guy doesn't distinguish it. What distinguishes this guy, R? You look at R, now we have trouble here. Let's see. This guy is going to come down, but it's pointed up, and so this come down from this guy, and this guy is going to go, so the electric field line will go like that. So over here, over at X, you have something like that of different magnitudes. This one will say they have the same magnitude, but you have two different orientations, so you expect different magnitude. You expect a stronger magnitude along the same line. So over here, of course, it can't be this, can't be this, can't be this. It's just between 3 or 4. So this is 3 or 4, more likely 4. So it's showing that this is more likely, but I haven't really worked out that it's going to be 2 to 1. Maybe 5 S will tell me 2 to 1. So S, both in the same direction. So this guy is going to go X, this I hat, and this guy is also I hat. So it's going to be I hat direction, so it's going to be this. So if I now look at the magnitude of this guy, this is 2 times one of these guys. So 2 times E of one dipole that way is P over by epsilon naught R cube, right? So one of dipole is just 2 here. So all of this guy is written at 4 pi down here, 4 pi down. So let make sure that's it's going to be P over 4 pi epsilon naught R cube times 2. So the factor 2 will come with the I hat direction in here. So this is correct. So this is going to be 2 I hat minus j hat in the case of R. So R will have to be 4. So that's the answer. And D is not the answer. So we checked out. How about Q? Q is 1. You don't have to check because Q doesn't distinguish anything here. But if you want to check, you'd say, well, let me use a green color. This is something I didn't have to check. This goes down, and this guy actually going up. So we had this dipole and this dipole. From this dipole, the electric field went down, minus I hat. From this dipole, electric field went up, plus I hat. I mean j hat. I hat this way, j hat that way. So this should be 0. So if that's the case, this guy, not this guy is. So Q goes to 1. All right. This was a pretty straightforward, simple problem, just ruling things out. The formula for electric field for a dipole in arbitrary direction is a little complicated. So you have suppose you have a dipole, and you want to look at what's the electric field vector over here at a distance r. And that's a little complicated formula. You may want to check this website out, and I have a derivation of that. This is my website. I will not write it here for the sake of brevity. All right, so this will be it. Take care. Okay, bye.